Let's talk about something that's probably hiding in plain sight in your APIs. It's a tiny detail that could be giving away your biggest business secrets. I'm talking about your IDs and the secret math that can protect them.
I mean, seriously, think about this for a second. Could a competitor look at your public-facing API and basically predict your business's health, your growth, your transaction volume? If you're using simple sequential IDs, the answer is almost certainly yes.
You've seen this a million times, right? An order, a user, whatever it is, all identified by a number that just goes up. It feels clean, it feels simple, but this exact structure, this predictability, is a huge vulnerability. And that's the absolute heart of the problem. That number isn't just a pointer to a row in your database. No, it's a signal. It's broadcasting your internal state to the entire world. It's a trail of breadcrumbs that anyone, including your competition, can follow. Okay, so what's the big deal, really? Well, it goes way beyond just looking a bit unprofessional. We're talking about tangible security threats and serious business risks. First up, you have enumeration attacks. This is the most obvious one. If an attacker sees an endpoint like /orders/1001, what's the first thing they're going to do? They're going to try /orders/1002 and then 1003, and so on. If your authorization logic has even a tiny mistake, they can scrape your entire data set. And here's where it gets really scary for your business. Imagine your competitor creates an account. They place an order on Monday and get order ID, say, 5,000. They place another one on Friday and get order ID 6,000. Well, guess what? They now know you processed about 1,000 orders that week. You are literally broadcasting your sales volume. Now look, engineers know this is a problem, and we've all reached for the usual suspects to try and solve it. But these common solutions, they come with some pretty hefty trade-offs. So let's break this down. UIDs are great for randomness, but they're terrible for your database. There's 16 bytes, and their random nature causes massive index fragmentation, which absolutely kills performance at scale. Then you have things like hash IDs. They're better, but now you're dealing with strings, which are slower to process and index. But then, look at id-obfuscator. It keeps the original 8-byte long data type. That means it's just as fast and efficient to index as your original ID. It's a huge win. So if the common tools have these kinds of drawbacks, what's the answer? Well, it's not a bigger, more complex framework. The answer, it turns out, is in the beautiful, simple, and powerful application of number theory. Okay, don't let the name scare you. This is the secret sauce. The entire system is built on this one mathematical guarantee. If you have two numbers that don't share any common factors, we call them coprime, you can use something called the extended Euclidean algorithm to find a special inverse number. And this inverse has a kind of superpower. It can perfectly undo a multiplication within a specific range, or modulus. It's pure, predictable, beautiful math. And here's how that magic trick actually works. To hide your real ID, you just multiply it by some secret number, the multiplier. To get it back, you multiply the result by that magic inverse we just talked about. And because of that key property at the bottom, that the multiplier and the inverse cancel each other out to equal 1, you are mathematically guaranteed to get your original ID back, every single time. So how do you actually implement this? Well, you don't have to. A developer named Arna Beer has already packaged this elegant principle into an open-source library called id-obfuscator. It's a super high-performance, rock-solid way to mask your IDs without giving up performance. The benefits here are just fantastic. The transformation is 01, which means it's incredibly fast and doesn't slow down no matter how big your IDs get. It keeps your IDs as native longs, which your database will absolutely love. It has 0 dependencies. Your build file will thank you. And importantly, the implementation is immutable and thread-safe, meaning it's built for serious, multi-threaded enterprise applications right out of the box. And for you folks running systems at a massive scale, check this out. A naive multiplication, like ID times multiplier, could easily overflow a 64-bit long once your IDs get big enough. This library is smart. It uses a clever algorithm to perform the multiplication in a way that prevents overflow, ensuring the math works perfectly even for gigantic ID values, right up to the maximum size of a Java long. All right, enough theory. How hard is it to actually get this into your project? The great news is it's ridiculously simple. First, you just add the dependency to your project. It's published on Maven Central, so any standard build tool like Maven or Gradle can pull it in instantly. This isn't some random code from a blog post. It's a proper, versioned, production-ready artifact.
First thing you do is create a codec instance. You just need to give it 2 secret prime numbers. You do this once when your application starts up, store it somewhere, and then reuse it everywhere. The factory even validates your numbers to make sure the math will work.
Now, the fun part. To encode an ID, it's just one line of code. You pass in your real database ID, and you get back a scrambled, public-facing long that looks completely random. That's it. It is lightning fast. And you get it back? You guessed it. One more line. When a request comes in with that public ID, you call decode, and you get your original internal ID back. Guaranteed. The round trip is perfect.
You know, what I love about this is that it's more than just a clever little library. It really represents a more thoughtful, more disciplined way of thinking about engineering.
This quote from the author just hits the nail on the head. We didn't need to add a heavy crypto library or some complicated new framework. We solved a real, practical problem by going back to first principles and applying some foundational mathematics. It's simple, it's fast, and it's provably correct.
The entire project is completely open source and waiting for you on GitHub. You can find it under id-obfuscator. You can read the code, see the tests, and understand exactly how it works. There's no hidden magic.
And as I said, it's officially published on Maven Central. This is your signal that it's a stable, trusted library that's ready to be used in your production systems today.
So I'll just leave you with this thought to chew on. We've seen how something as obvious as a sequential ID can be a huge information leak. It makes you wonder, what other simple, obvious design choices in your systems are quietly telling the world more than you'd like? Thanks for watching.